Hey guys, welcome to day 41. I'm coming at you with L'Hopital's rule today, which is a rule that you're going to find, I think, to be very nice. It's a way to evaluate limits that are in what's called an indeterminate form. So the first thing to know about L'Hopital's rule is it can only, and this is really, really important, and a lot of times they might try and trick you on the AP exam with this. L'Hopital's rule can only be used in an indeterminate form situation. Indeterminate form would be 0 over 0 or plus or minus infinity over plus or minus infinity. Okay, so that's the first thing to keep in mind. And if this comes up on the free response portion of the AP test, you're going to have to show that we're in that indeterminate form, and you'll have to state that you're using L'Hopital's rule. So we'll practice that a lot, right? You don't have to worry about that so much if it was on the multiple choice, but on the free response, you have to be very careful on how you do this. Here's what L'Hopital's rule is. If we get a limit as x goes to a, we're doing a limit as x goes to a of f of x over g of x, right? A function over a function. Okay? When we plug in a, right, we get f of a, whatever that is. Uh-oh, what's going on here? Sorry, my screen just cut out. Let's see. Push on some wires here. Okay. We get f of a over g of a. And when we evaluate that, let's say we get either 0 over 0, or we get an answer of plus or minus infinity over plus or minus infinity. In those scenarios, right, let's say we plug in what we're doing the limit of and we get 0 over 0. Then what we can do is this. We can use L'Hopital's rule. And what we can do is we can do a new limit of the derivative of f over the derivative of g. And we can keep doing this, right, as long as it keeps making an indeterminate form, 0 over 0 or plus or minus infinity over plus or minus infinity. We can keep using L'Hopital's rule over and over again until we get to a solution that works. Okay? What I need you to understand, this is not the product rule, right? We're not executing the product rule. We're simply doing what's the derivative on top and the derivative on bottom, and then we're plugging in. So the quotient rule is still a thing, where this is different than the quotient rule. It's just we're doing the derivative of the top, the derivative of the bottom, then we plug in. And if we get an answer, then that answer is we'll call it L for limit, that is our answer. Let me show you what I mean by this. Take a look at a couple of examples here. And I'll show you how we used to solve them and how we can solve them now. So this is a problem that, right, we saw problems like this at the very beginning of the year. And we started solving the limit by plugging in, right? We plugged in and we had 4 squared minus 16 over 4 minus 4, which gave us 16 minus 16, which is 0, over 4 minus 4, which was 0. Right? And we came up with that indeterminate form, 0 over 0. Well, what we did is we then factored and canceled, right? So solving this the way we used to solve it, right? We'd say, oh, x squared minus 16, that's just x plus 4 and x minus 4. And what we did then was we canceled our x minus 4s, and we plugged in 4 plus 4 equals 8. And that was the answer that we got. Okay? But I want to show how this could work using L'Hopital's rule. So that's one method you could use to solve it. So this is the old method. And it worked just great. Can still be used. But L'Hopital's rule could also be used here because we came up with that indeterminate form. Once again, in order to use it on the free response, you would have to do this work up here first. You're going to have to show that you get 0 over 0. Then after doing that work, you could say, using L'Hopital's rule, what you could do is the limit as x goes to 4. And what we can do now is do the derivative of the top and the derivative of the bottom. The derivative of the top here is 2x. Right, minus 16 is a constant. It goes away when we do the derivative. Right? I'm doing the derivative of our original function up here. I get 2x for the derivative of the top, and I get 1 for the derivative of the bottom. Well, 2x divided by 1 equals 2x. Right? Then plugging in, I get 2 times 4. And I get that same answer of 8 that I got factoring and canceling. Okay, but I think it might be a little bit simpler of a method to do. Okay? Let's take a look at another one of those. So here we have the limit as x goes to 0 of x over sine x. Now this is one that we would have trouble factoring and canceling, right? Our old methods here wouldn't work very well. And without a calculator, we'd be kind of stuck on how to do this one. So let's take a look at what happens. Well, let's first off, if we're going to use L'Hopital's rule here, you can't just do the derivative right away. You have to first show that this is a 0 over 0 scenario. So plugging in 0 for x, we get a 0 on top, and we get sine 0 on the bottom. We know that sine of 0 equals 0, so we get 0 over 0. So we're in that indeterminate form where L'Hopital's rule can apply. So again, I want you to get in the habit of doing this. Number 1, you got to show that we have an indeterminate form. Step 2, you must tell the grader that you're using L'Hopital's rule. Right? We can use it because we got 0 over 0 when we plugged in. Now we're just going to do the derivative of the top and the derivative of the bottom. Again, this is not a quotient rule. This is simply doing the derivative of the top and the derivative of the bottom. The derivative of the top, we get 1. And the derivative of the bottom, the derivative of sine x, is cosine x. Okay? And now we're going to plug in to see what we get. Well, we end up with 1 over cosine 0. And we know from our unit circle that cosine 0 equals 1, so I get 1 over 1, which equals 1. And that is the correct answer. So again, L'Hopital's rule can be pretty powerful here. But I also want to take a look at some other examples that on the surface kind of look a little messy, okay, or a little bit confusing. But I'll show you how we can use L'Hopital's rule to solve them. Here's example 3. So here's our problem. It says when x equals pi, evaluate the limit as h goes to 0, a sine of x plus h minus sine of x over h. Okay, so we have lots of things going on here. We have x, and we have h. The first thing I want to do is sub in x equals all the x's for pi's. And rewrite this limit. So I'm going to rewrite this thing as limit h goes to 0. And again, I'm just going to plug in pi for these two x's. So it's going to be sine of pi plus h minus sine pi over h. And I'm supposed to let h go to 0. So plugging in 0 now for h, I get sine of pi plus 0 minus sine of pi over 0. And again, pi plus 0 is just pi. So sine pi minus sine pi, right, would be 0 over 0. So I get that indeterminate form, so I know that L'Hopital's rule can apply here. What I want you to understand here is that this is a problem that says limit h goes to 0. We're just going to treat h like the variable x here and just do the derivative as we go along. So here's what we're going to do. I'm going to do the derivative. I'm going to derive with respect to h in this setup right here. But first, I got to say I'm using L'Hopital's rule. And I'm going to say the limit as h goes to 0 then. I'm going to do the derivative of the top. Now, h is my variable, so this looks like it's going to be a chain rule, because I have pi plus h. But the chain rule is pretty simple here. I do the derivative of the outside with respect to the inside times the derivative of the inside. Again, pi is not a variable, but h is. The derivative of h would simply be 1. So I could say times 1, or I don't need to put it. The second part up here, that minus sine pi is simply a number. So its derivative is it's a constant, so its derivative is 0. I can say minus 0, or I can just leave it blank. Okay. Remember, sine pi is simply a number. It's a constant. So deriv equals 0. And then the derivative of h on the bottom would be 1. So basically, this all simplifies down to cosine of pi plus h. And again, I'm going to plug 0 in for h, and hopefully it works now. The cosine of pi, if we think about that on our unit circle, pi is over here. That's the point -1, 0. Cos is always x. Sine is y. So the cosine of pi plus 0 is the cosine of pi, and the cosine of pi equals -1, and that's my answer. Oftentimes on these confusing ones, a lot of times people say the derivative of sine pi is cos pi. Okay, but again, there's no variable there. That's a constant. Pi is a constant hiding out in disguise. So just be careful with that. Oftentimes, only one of the two things on top has a variable in it. Let me show you another one. And I like to kind of disguise these things, but we just plug in and solve. It's not so bad. Again, here's my problem. If f of x is e to the 2x, evaluate the limit as x goes to 4 of f of x minus f of 4 over x minus 4. Okay, well, the first thing I want to do is sub in for f of x. Since I know f of x is e to the 2x, right, that was given. What I can say here, I'll use a different color. F of x then is e to the 2x minus f of 4. F of 4, right, doing that up here. I have f of x, that would be e to the 2 times 4, which is e to the 8, over x minus 4. I'm done. So again, I'm just making a simple substitution for both f of x, which is e to the 2x, and f of 4, which is e to the 8. Now I want to try evaluating this limit by plugging in. So when I plug in 4 for x, I get e to the 2x, so 2 times 4 would be 8. I get e to the 8 minus e to the 8 over 4 minus 4. I don't know what, e to the 8 is a huge number, but I know when you do e to the 8 minus e to the 8, you're going to get 0. And 4 minus 4 I know is 0. Okay? So once again, we're in an indeterminate form. So I can solve this problem then by using L'Hopital's rule. So what I'm going to go ahead and do here is do the derivative at the top and the bottom and see if that fixes it. So the derivative of e to the 2x, once again, that's a chain rule. It's going to be e to the 2x. E is its own derivative, okay, when it's to a variable. But then I need to multiply by the derivative of 2x, which is 2. And once again, e to the 8. When we look at that, e to the 8 is a constant, so its derivative is 0. Over the derivative of the bottom, I get 1. Right, the minus 4 is a constant, so its derivative is 0. So cleaning that up a little bit, I get 2e to the 2x over 1, which I can just call 2e to the 2x. Now I'm going to go ahead and plug in 4 for x. And I'm going to get 2e to the 8 as my answer. So we can see that L'Hopital's rule can be very helpful for us for solving some of these tougher limit problems, right? But just make sure, number one, you can only use it if you have 0 over 0 or infinity over infinity. You must state that you're using L'Hopital's rule on free response. And just make sure you keep writing this limit notation as you go along. And that's it for today. I'll see you guys tomorrow. Bye.